All right, so we're going to do example 9. This is the last example in the 11.1 notes, and it's a big example. It's an important example because dimensional analysis comes up a lot, at the end of elementary school, through middle school, through high school, and it's one of those things that also comes up in just everyday life too when we're converting. I know we all have phones and we can Google all this, but I would really encourage you when you're converting to try to use to actually do it the long way rather than just Google and have Google tell you the answer on the test. And on exam 3, when you do the test, you're going to have to show your work and show that you know how to convert. So I would definitely try to practice that in your notes and your homework too. So let's start with the first one. So what I would do with dimensional analysis is I would write down what you're given. And write it as a fraction. So 3.6 pounds, I would write 3.6 pounds, and I would write it as a fraction. If it's not a rate like the one below where it's feet per second, meaning feet on the top, second on the bottom. So in this one, we don't have anything to put on the bottom, just put a 1. And then what you want to do is we're going to be multiplying. We're going to be multiplying by sometimes one fraction, 2, 3, 4, it just depends on the problem. We're going to be multiplying by unit rates. And what I mean by unit rate is we're going to look for some sort of conversion, okay, that has to do with the problem. And in this problem, we're given pounds and we want to write our answer in ounces. So that means we want to get rid of pounds. So I'm going to put a pounds on the bottom because I want these to cancel out. Okay, when we multiply fractions, the numbers on the diagonals cancel. So for example, I'm just going to come up here. If we had 1/2 times 2/5, those 2's would cancel, and then you'd multiply the top and you get 1, and you multiply the bottom and you get 5. So the units also cancel. So then I asked myself, well, do I know a pounds to ounces conversion? And I do. So 16 ounces are in 1 pound. So I'm going to put 1 pound on the bottom, 16 ounces on the top. And 16 ounces and 1 pound are the exact same thing. So essentially it's like a fraction of 1/1. So that's why it's okay to multiply 3.6 by this fraction, because we're really not changing 3.6. We're changing what it looks like, but we're not really changing the quantity, since 16 ounces over 1 pound is really just 1. So now we're gonna, we've crossed off our units. You can look at the units that are left over. So what's left over is ounces, which is good because that's what we want. And then we're going to multiply. So the top times the tops gives you the top. So 3.6 times 16 is 57.6. 1 times 1 is 1, so essentially we don't even need the bottom. And then ounces are left over. So our answer for this one is going to be 57.6 ounces. Okay. Let's move on to the next one. So I'm going to write 40 kilograms per meter. So whenever you see this diagonal line, you can write it just on top of each other vertically like this. And then I'm going to put a time symbol. And then I'm going to ask myself, well, what do I want in the end? So in the end, I want grams per meter. Well, I already have meters on the bottom, so that's good. But I just have to get rid of the kilograms and convert that to grams. So because I want to get rid of the kilograms, I'm going to put the kilograms on the bottom. So then those end up canceling out. Okay, and then I'm going to find a kilograms to grams conversion if I have one, and I do. This is up in the notes. So 1 kilogram is equivalent to 1,000 grams. So I'm left with grams, which is awesome. That's what I want, and I'm going to multiply my fraction. So 40 times 1,000 is 40,000 divided by 1 times 1 is 1. And then the units that are left over are grams. So 40,000 grams is going to be the answer for that one. And this would be a great place. Google is awesome. You can certainly use it to check your answer. So you can plug in 40 kilograms per meter and ask for the conversion to grams per meter. And I'm sure you could find that online. Okay, so the next one, 144 feet per second. So 144 feet per second. You can put 1 second if you want, or just leave it seconds. Now with this one, we don't want feet in our final answer because we're changing feet to miles, and then we don't want seconds, we're changing that to hours. So, what I would suggest is pick one of them to get rid of first. So let's pick feet. So if I want to get rid of feet, I'm going to put that on the bottom. And putting that on the bottom allows these to cancel which is what I want because I don't want feet in my final answer. And then I asked myself, well, okay, so if I don't want feet, what do I want? Well, I want miles. Do I have a feet to mile conversion? I do. So 1 mile is the same thing as 5,280 feet. Okay, so I'm left with miles. I'm good with the distance, so that's what I want is miles. Now I'm going to look at seconds. I don't want seconds, so I'm going to put seconds on the top. And even though the fractions are not right next to each other, the seconds cancels with the seconds. And then I'm going to ask myself, well, what do I have a conversion for? I know how many seconds are in a minute, so I could put minutes on the bottom. There are 60 seconds in 1 minute. Now, at this point, I'm left with miles on the top and minutes on the bottom. I don't want miles per minute. I want miles per hour. So I'm going to multiply again, and I'm going to put minutes on the top so that the minutes on the bottom cancel with the top. So I'm getting rid of the minutes, and I'm going to find a minutes to hour conversion. So there are 60 minutes per 1 hour. And so now when you look at all of these fractions, the units that are left are hours on the bottom, miles on the top, and that's exactly what I want, miles per hour. Okay, so now I'm going to multiply all the numbers on the top. So I'm going to multiply 144 times 1 times 60 times 60. Okay, and then I'm going to multiply 1 times 5,280 times 1 times 1. And you know what? I didn't actually write down what those individual numbers equal, but when you divide those, you should get 98.2 miles per hour. So just to clarify, I'm multiplying 144 times 1 times 60 times 60. Write that number down, and then multiply 1 times 5,280 times 1 times 1, and you're going to divide the sum or the total that you got on the top by the total you got on the bottom, and you should get 98.2. Okay, so for the next one, 35 miles per hour, I want inches per second. So I'm going to pick a unit. Let's pick miles. Doesn't matter which one you pick. I'm going to get rid of that first by putting miles on the bottom. So those cancel. And I don't know a miles to inches conversion, but I do know a miles to feet. I know that there are 5,280 feet in 1 mile. Now, at this point, I'm going to say, well, I don't want feet. I want inches. So I'm going to put feet on the bottom. So those go away. And then inches on the top, since I know there are 12 inches in 1 foot. So I'm left with inches, which is perfect. That's what I want my final answer. Now, I still have hours on the bottom. I don't want hours since I'm wanting inches per second. So I'm going to put hours on the top here, so those cancel. And I know that there are 60 minutes in 1 hour. Now, I still don't want minutes, so I'm going to multiply again, and I'm going to put minutes on the top, so those cancel. There are 60 minutes, or I'm sorry, let me erase that. There are 60 seconds in 1 minute, so the minutes cancel, and I'm left with seconds on the bottom. Now, all said and done, if you multiply all the numbers on the top, so 35, 5,280 times 12 times 1 times 1, you end up getting 2217600 divided by, we've got 1 times 1 times 1 times 60 times 60, so that gives us 3,600. And if you divide those two numbers, you end up getting 616, so 616 inches per second. Okay. All right, let's look at the next one. So 72 pounds per feet. And you know, I'm going to write it like this because that pound, my L looks a little bit like a 1. Okay, 72 pounds per feet for cubic feet. And I want to change it to tons per cubic yard. So I'm going to pick one unit to start with. So maybe I start with pounds. So the pounds is going to need to change. Let me just write it like this. The pounds are going to need to change to tons. So I know there are 2,000 pounds in 1 ton. So I'm going to put pounds down here so that they cancel. And I'm going to put tons on the top. So there are 2,000 pounds in 1 ton. So I'm left with tons, which is great. Now I want to get rid of the cubic feet. So I put cubic feet on the top. And I know a conversion of cubic feet to cubic yards. We did that on the first page of the notes. So there are 9 cubic feet and 1 cubic yard. And the cubic feet end up canceling. So when all said and done, I'm left with tons on the top, cubic yards on the bottom, and that's what I want. So now I'm going to multiply the entire top together. So 72 times 1 times 9, and divide that by 1 times 2000 times 1. And when you do that, you should get 3.324 tons per cubic yard. So 0.324. All right, so one more. So the last one, I'm going to write 65 kilograms per liter, or per 1 liter, okay? And my goal is to get grams per cubic centimeter. So I need to change kilograms and liters in the end. So I'm just going to pick one to change first. So I'm going to pick kilograms to change first. So I'm going to put kilograms on the bottom, and I'm wanting grams in the end. So do I have a gram to kilogram conversion? I do. This is above in our notes at the top of this page. So I know there's 1,000 grams in 1 kilogram. The kilograms on the diagonal cancel out, and I'm left with grams, which is great. That's what I want. Now I want to change liter, so I'm going to put liter on the top and ask myself, okay, do I have a liter to cubic centimeter conversion? I do. So I know that 1 liter is the same thing as 1,000 milliliters or 1,000 cubic centimeters, since cubic centimeter and milliliter are the same thing. So 1 liter is 1,000 cubic centimeters. The liters end up canceling, and I'm left with cubic centimeters on the bottom, which is what I want. So when you multiply the top and divide by so 65 times 1,000 times 1 divided by 1 times 1,000. So let me just write that out. So 65 times 1,000 times 1 goes in the numerator, and then 1 times 1,000 goes in the denominator. And actually, you can even just, if you want to use a calculator, go ahead, you can even cancel these, and you end up getting 65. So 65 grams per cubic centimeter. So I hope this helps. Keep in mind you might have to watch a couple of these over again, slow the video down. You could pause and do it yourself and kind of double check as you go. I think the key is having all of these conversions down before you start. So if you have one sheet of paper where you just have a log of all of these, I think that could be really helpful. And it's always good. You can always Google these, to actually double check your answers and make sure you're on the right track.